we are going to study about the amine synthesis. So at disconnection approach, so firstly, what are amines? Amines are the derivatives of ammonia. They can be aliphatic or aromatic, and they are divided into primary, secondary, tertiary, and quaternary based on how much carbonated they are, how much alkyl or aryl groups are bonded to them. If one alkyl group or aryl group is bonded, then it's primary. If two, then secondary. If three, then tertiary. If four, which is obtained after exhaustive methylation and quite unstable, it is quaternary. It is also known as they are defined as 1 degree amine, 2 degree amine, 3 degree amine, or 4 degree amine. Now, what are the method of amine synthesis? Conventionally, we use alkyl halide for the amination of alkyls or aryls, like here is seen in disconnection approach. In synthesis, we use alkyl halide for the amination. And why? What is the problem with this method? The thing is that this method doesn't stop at this step. It keep going until it gives the quaternary amine, but we don't need that quaternary amine. We only need a one step amination that can give a 2 degree amine or 1 degree amine, like that, and it is quite not possible in it, but it can still, we can still use alkyl halide if we take care of electronic effect or steric effect, right? Since nitrogen in amine is nucleophilic, so it's really reactive and it goes further to react with the alkyl halide to give tertiary or quaternary ammonia. So if we use a COH, like COH in electro withdrawing group, and it has a minus I effect, so it makes NH2 slightly positive, so it makes it less reactive, and it the reaction don't go further, so electronic effect is taken care of. Or otherwise we can do if a bulky group is bonded to nitrogen, then also we can follow. Or other than conventional, what are the methods we can use? Because there are many instances where we don't have bulky group, or we don't use electron withdrawing group. Then what is the problem? What is the solution to this problem? So we use electrophiles so that we can get products with the low reactivity. The electrophiles like acyl halide, aldehyde, and ketone, they give amides or imines, which gives us amines as product, which are lowly reactive. So how we can get that is, see, we used a 1 degree amine and we reacted it with acyl chloride. It gave us a amide, and reduction we obtained a 2 degree amine from a 1 degree amine, and the reaction stops here. Okay, just like that in aldehyde, if we use aldehyde, we get an imine upon the reduction. We can get either linear amine or branched amine based on whichever reduction or addition product we used. Okay, and just like in that, in ketone, we get imine. Imine is then reduced to get a branched amine. Also, since both amide and imine give different types of products, like one give linear and another give branch product, so while disconnection we use FGI to differentiate which method is used for the synthesis of the target molecule. For example, in this, if we use FGI upon A, or if we use FGI upon B, if we follow the first pathway, then we get a amide, and from B pathway we get imine. And when we synthesize, upon guidelines in disconnection, we have studied that we should follow the pathway which is easy, and so the pathway of imine is much easier because we don't have to isolate imines in them, so we follow the imine path. I'll study the methods of primary amine synthesis. Primary amine can be synthesized some methods which are known to us. First is Amine method. We have just studied the Amine method, in which the reduction of amine will give us a branched amine. Next is amide. Well, we just studied the amide method too, which gives us linear amine, but it results in the low yield of amine, so it is not quite useful. And for the formation of linear amines, we can use cyanide method. So upon the reduction of aryl cyanide or alkyl cyanide, we can get the branched amines, and alkyl cyanide or aryl cyanide can be obtained as such. Alkyl halide on reaction with cyanide and can give us alkyl cyanide, and aromatic amines upon diazotization can give us aryl cyanide. And FGI is also required for the disconnection of amines through cyanide. So upon using FGI on this target molecule through here, we can get this cyanide, and this disconnection results in the formation of a ketone, and this cyanide ion HCN we can use, and thus we can form the target molecule. And another method is the formation of oximes. Oximes give us branched amines just like amines. So oximes are quite good intermediates since they can be made easily from ketones. Here we have shown that this ketones, when it reacts with the hydroxylamine, it gives us oxime, and the reduction of this oxime gives us branched amine. Here is branched primary amine. Here also FGI is required before disconnection. The example is this is an important example. This is fenfluramine. Here is a target molecule, and we disconnect it from the ethyl firstly, and we get a ketone upon using FGI, and then we disconnect it from here from the CN bond disconnection, and then we can get this molecule, and upon FGI here, using FGI here, we can get this oxime, and oxime, of course we just studied that oxime can be disconnected into ketones, and here we have synthesized the ketone to oxime, and oxime give us amines upon reduction. Next is from nitro compounds. The reduction of nitro compounds give us primary amines. Well, here are two types of products we can get from this method. Well, if we just use a base, then it can give us a primary amine upon direct reduction. But if we can also also use alkylation method, like we alkylate it and then use base and then reduce it. It can give us a branch. Now, FGI is also needed when we disconnect amine to form nitro compounds. Like for aliphatic nitro compounds, here it is aliphatic, though aromatic group is also attached to it. Upon using FGI here, we can get a nitro compound, and upon disconnecting it from here, we get a alkyl halide and a nitro group, and it can be synthesized from these steps easily. Now for aromatic nitro compounds, the simplest example here is aniline, and aniline, upon using FGIs here, we get a nitro compound, and upon reduction of nitro, we get a ammonia group. Now from Ritter reaction, the hydrolysis of amide gives a primary amine upon using Ritter reaction. Ritter reaction gives us an alkylated amine from a nitrile. So here it is shown, right, from a nitro compound upon its alkylation and its reduction, it gave us a branched primary amine. Same product can be obtained from the Ritter reaction. Here alcoholic group, and upon the using of MECN, we get a nitrile group, and its a hydrolysis gave us a amine. From azide are N3 and N3 and azide ion, that is N3 negative, it acts a reagent for amide ion. Okay, so upon using NaN3, it has azide group, and in we about after using it on alkyl halide or aryl halide, we get a alkyl azide or aryl azide, and its reduction gives us an primary amine. See here, we have seen it in through Fg, I have shown it. Here is an primary amine, and it's using FGI we can convert it into azide group, and its disconnection gives us an azide ion and this hydroxyl ion. Now last method is from phthalimide ion. Though phthalimide is used for formation of secondary amines, right? Here it is used for formation of primary amines too. Here phthalimide is obtained from phthalic anhydride. From phthalic anhydride we get phthalimide, and phthalimide gives us phthalimide ion. So the phthalimide ion reacts with alkyl halide or aryl halide to give us alkyl phthalimide or aryl phthalimide, and the use of hydrogen with it gives us this and a primary amine too. Now examples are through disconnection. So first example is benzocaine and COET, CO disconnection. CO disconnection can give us ETOH and this carboxylic acid. So now this is the simplest starting material. Now we disconnect this. So we use FGI here at NH2. NH2 gives us nitro compound, and nitro compound now we use, since this is the most reactive, we disconnect it, or we use FGI upon it at the last. So we use FGI here and convert it into methyl group. Now this upon in between methyl and nitro we can remove this to give us a toluene. We have taken such example in simplest disconnection too. So toluene is easily available, and upon nitration it gives a para nitrated group, and its reduction can give us amine, but then it will reduce it to CH3 too. Okay, and we don't want that, so we firstly reduce it into COH, then we reduce it into NH2. Therefore, and then we use E2H to form our target molecule. Next example is a diamine, and we use FGI on shorter chain here, and upon FGI we get a nitro compound and a double bond, and we can disconnect it here to get a ketonic group, or in this case aldehyde group. Now we can use FGI here to get us a nitro compound or a cyanide compound. We use cyanide here, which is much easier. Now we disconnect it here to give us a cyanide compound and a aldehyde group. We can synthesize it here from aldehyde and cyanide group to give us the 15th product, that is this. Now, and we then use this nitromethane here to get us a nitromethanic OH here and a nitromethane group here. Now we need to get rid of this OH, so we use P2O5, and then it is reduced to give the target molecule, that is the diamine. Third example is the synthesis of N 4-hydroxyphenyl acetamide. Yeah, and we can disconnect it here by using the FGI here, and it will give us a carboxylic group. Yes, and here we get this the simpler amine, and we use FGA here to get a nitro compound, and this nitro compound can be obtained from phenol group. Here I have shown the synthesis from phenol. Its nitration gives us nitro paranitro. Yes, and its reduction gives us 4-aminophenol, here amine at para group. Now we use this acetic anhydride to give us this target molecule. Yeah. Now the synthesis of last example, it is dicyclohexylamine. First, by using FGI here we get a imine, and upon disconnection we get a simpler cyclohexylamine, and we can it is easily available too, and we can further disconnect it too. And the third, another one is cyclohexanone. It is too easily available. So this addition product gives us imine, and by reduction of imine we get dicyclohexamine. Here I am going to end this. Thank you.